Hello, my name is Brian Dane. This video is part of my master's project for San Jose State University and my Master's of Music Education. I hope you enjoy it. And if you have comments or suggestions, I look forward to answering them as we learn this together. My contact information is at the end of this video. I encourage you to read the accompanying paper first, then come to these videos. So this first video is our introduction to tuning when it comes to choirs. Singing in tune is one of the largest issues choral ensembles must address. This is particularly important when ensembles choose to sing a cappella or without accompaniment. If we perform with a piano, we should tune to the piano. If we sing with a string quartet, which uses a different tuning system, we really should sing with that tuning system. Most of the changes are done by ear, and we adjust because we are adaptable beings. Over the past decade in this profession, I have experienced specific issues when it comes to tuning choirs, both in my own ensembles and those of my colleagues. We know how to analyze compositions, but we do not analyze how to tune. There are books of choral tuning exercises, but only one that I have found discusses the disconnect between natural harmonics and the incompatibility with the piano. This book by Matthew has been extremely enlightening. This is the book on how to listen. The concepts of each tuning system are explored in exhaustive detail. To hear the difference between a just intonation third or an equal tempered third, read this book. And we have to learn how to hear different thirds because it was not until 1917 that the system we know as equal temperament was systematically defined. Now, this is all to understand the conclusion that, simply stated, a work written in the 16th century should not be subjected to the tuning ideals of the 20th century. So, what is arguably one of the most important issues facing choirs is derailed by the very instrument used as its ideal. Directors pound notes on the piano, raised eyebrows, and admonish the choir for low energy or poor support. The issue is that they are using an unnatural system on which to tune. There is a natural system, and it is based on science, rational numbers, and, well, nature. I go into all of the supporting facts and history in my paper. This video and the next 4 will be more of the application of the technique. Let's meet everyone where they are. Equal temperament. The piano uses an intonation system in which the octave is divided, the pitches are tempered, into 12 equal steps. As any music student will tell you, there is considerable overlap in style, harmonic language, and compositional practices throughout all the time periods. That same overlap exists in tuning as well. We must first address this by dividing tuning systems into rational and irrational categories, literally using rational and irrational numbers. A tuning system is rational if the pitches used in the system coincide with the overtones, which are whole number multiples of the fundamental, thus resulting in a rational mathematical ratio. Let's look at the actual definitions of the word rational. Number 1, it's a system, or I would add a decision, based on or in accordance with reason or logic. Or number 2, our mathematical definition, expressible as a ratio of whole numbers. So let us focus on that second mathematical definition, that a tuning system is irrational if some mathematical formula has been applied to the intervals of any scale. The systems of just intonation and Pythagorean tuning are mathematically rational as they are based on ratios built on naturally occurring overtones. The system of equal temperament is a mathematically irrational system in which intervals are tempered mathematically, so they are even across an octave. There is no ratio based on the natural occurring overtones. Now, before one is to suspect that equal temperament is an inferior system, that is absolutely not the case. Equal temperament solved many musical issues as harmonic, modal, and tonal boundaries were pushed by composers and audiences starting in the late 16th century. We wanted and needed the equal temperament system to be designed. The problem is that many use the piano for repertoire written before the system was codified and widely accepted. In fact, I agree with many that a firmer grasp of all three systems will indeed make our understandings of each not only richer, but it'll result in a musician that is more sensitive, nuanced, knowledgeable, and expressive. As I stated earlier, the concept of equal temperament is now most closely tied to the piano. The idea is that each step in between an octave is even and equally spaced. The simplicity of equal temperament is seen in the context of sense. So with this table, we can see that a C sharp or a D flat is 100 cents away from C. And then another 100 cents lands us up to D. So C to D, 200 cents. C to E, 400 cents. C to F, 500 cents. So you take that C to E, that major third, and you can duplicate that anywhere. A G to a B is also 400 cents. This is the most common tuning system used in Western music, and it is the standard system used for tuning a piano. Though considered mathematically irrational, its overall logic comes from being relatively simple and pleasing to the eye. The advantages of equal temperament are, 1, that each interval has one stable value, 2, that enharmonic equivalents have the same value, for example, a C sharp equals a D flat, and 3, that complete tonal mobility is available with modulation to remote keys, so every key maintains that same equal harmonic spacing. There's a great Scarlatti story that he gave a concert with 4 different harpsichord concertos, and because they were on all different keys, they actually had to retune the instrument in between every concerto. That would be crazy to listen to as an audience member, of course. So the ability to modulate was why equal temperament was designed. Essentially, it now sounded fine to go from any key to any key, which could not have been done before. But to do this, we had to literally change how all of the keys sounded. Equally good was achieved by making everything equally bad. By bad, I mean there are many that do not like how this system sounds. By definition, to temper an interval means to sing it out of tune with nature. It is hard to quantify preference, so a reversion to the math behind the theory is a good idea, as we need something objective. Equal temperament begins to get complicated when the theory behind the formula is viewed. Take any one thing and divide it by 12 equal parts, 1 divided by 12. You get 0.08333333. This is not possible to come up with a rational number. Even better math would actually be the 12th root of 2. The concept that an octave, right, the 2 is being doubled, right, is divided by 12. So we must use the 12th root of 2. This results in a mathematical inconsistency of about 1.0595 cents between each half step. What this shows is that it is impossible to divide or tune the 12-note scale so that all intervals can be truly harmonically pure. They are irrational numbers. They must then all be equally out of tune. This will become very clear as we move forward. But now that we have laid the groundwork why we need these other systems, let's go ahead and move on to all of our other videos.